This is question number 3 from the 1.5 MyLab math homework on general problem solving strategies. And in this question, they're going to ask us to use the strategy where we work simpler problems to distinguish a pattern that'll help us solve a harder problem. So let's read the problem. It says, instead of a problem is given below, instead of trying to solve that problem, state a simpler problem and solve it instead. 11 people are being honored for their work in reducing pollution. In how many ways can we line up these people for a picture? So this problem is actually not too bad. You could solve the answer using the multiplication principle without replacement, but we're not asked to do that. We're asked to figure out a simpler problem, and then we're being asked to solve the simpler problem. So here's the question. In how many ways can we line up these people? So another way to say that is we're being asked in how many ways. So in how many ways can 11 people line up for a picture? So how many ways can they line up? So the first thing we have to do is figure out a simple version of the problem. So a simpler version would mean just instead of 11 people, maybe only use, I don't know, maybe 4 people. Or even better yet, 3 people, right? That'd be way simpler to line up 3 people for a picture or 4 people for a picture. And then the idea is from patterns we see solving those simpler problems, we'd be able to come back up to the original one and solve it. Okay, so let's read what we have here. So what are our answer choices? In how many ways can 3 people be lined up for a picture? That sounds like this, right? And instead of in how many ways can 11 people be lined up, it'd be much easier to see in how many ways can 3 people be lined up. So I think the answer is A, but let me keep reading. In how many ways can 11 people be selected from a group of 15? That's definitely not easier. In how many ways can 3 people be selected from a group of 11? Well, the original one is just saying you have 11 people line them up. Like you're not picking those 11 people out of a bigger group. And here we're picking 3 people out of a bigger group. So that doesn't really match the pattern. And how many ways can 15 people be lined up? That's harder than 11, so that's not it. Yeah, so the answer choice must be A. So I'm going to go over here to my math lab and I'm going to mark A as my answer. Oh, no, let's see. Fantastic. Okay. And then now they want us to solve this simpler problem. They just want us to line up 3 people. So let's go ahead and do that. Okay, so if I have 3 people, I need to line them up. Person 1, person 2, person 3. So first, the first person, so first person, second person, third person. Okay, so I have 3 people. Here's person 1. I'm going to call this person A. Here's person B. Here's person C. Okay, the first time I go to select a person, how many people do I have to choose from? Well, all 3 people are there, right? So the first time I go to choose a person, there's 3 people to choose from. So let's say we choose person A. We line them up over here, person A. Oops, there he is, person A. Okay, now he's out. If person A is first, person A can't be second or third, right? So when I go to figure out the second person, now there's only 2 people left. So we're doing this without replacement. We're not putting this person back into the group. Once that person's in line, they're out. So let's just say we pick person B. So person B comes next. Okay, now that person's out. So when I go to choose the third person, there's only that one person left over there. Third person is just this one person left. So I only have one choice there. And the multiplication principle just says you multiply the number of ways to get the first person times the number of ways to get the second person times the number of ways to get the third person. When I multiplied that all together, there are 6 total ways. So the combination I chose, person B, person C, is just 1 out of 6 possible ways. You know, person B could have come first, and then A, and then C. Or person B could come first, and then person C, then person A. I mean, I could list all these combinations, but I know there's going to be 6 total ways to line up these people. So let me go ahead and make sure that's the right answer. I'm just going to type 6 in here. And that was correct. So this problem is just an example of that strategy where you work a simpler problem and then you try to find a pattern to get the the more complicated solution. And, you know, we could do this one. So I'm just going to pop over here real quick. See the pattern that we have where we were working a problem with 3 people. So we started with 3 people and we just decreased the numbers as we went. So we could totally do 11 people. We would just have to line up 11 slots. If there were 11 people, we'd line up 11 slots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And if 3 people starts with a 3, 11 people is going to start with an 11. And then if I decreased 3, 2, 1, I would decrease 10, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then I would just multiply those all together and would get some big ridiculous number of ways to line up 11 people. So it's a really big number that we're going to get. But working that simpler problem would help you see the pattern to solving the harder problem.